Okay, we're still on Objective 6, and we're learning a couple more things, mostly about patterns. But this one is still the same things we've been doing, where we got to find the center of the circle. Y'all already find it? J is correct. -2, and then 7/2 is the same thing as 3.5. Okay, so -2, 3.5. Now, how can you tell that that's the center? It does look like the center, but how can we tell for sure?
Count.
Okay, count up and down. Okay, so you'd count up from here. That would be 1/2, and then 1, 2, 3, 4, and then 1/2. This would be going down 1/2, and then 1, 2, 3, 4, and 1/2. Okay, same thing. Got to double check it though. Make sure it's the same distance up and down. Since they were all -2s, we knew they had to be at -2. Okay, number 2. Identify the location of point P under translation x plus 3y minus 2.
2, 0.
Okay, how did you get that?
To the right, 3 down 2.
Very good. And you end up at 2, 0. Questions? Okay. Okay, this is the new, kind of a new problem that we didn't have in the last part. There's a measure of an exterior angle. What's an exterior angle?
Outside.
Outside, good. It's shown for each of 3 regular polygons below. What's a regular polygon mean?
All their sides are the same,
All
are the same length, and
right.
their angles are the same.
All the angles are the same and all the sides are the same length. Good. Okay, it says which expression best represents the measure in degrees of an exterior angle of a regular polygon with n sides. Okay, but what do we need to know about these figures?
They're all regular.
Okay, but what do I need to write down here?
3 sides.
Okay, this one has 3 sides, this one has,
4,
and this one has 6. Make sure you count. Don't assume it's 5. Okay. All right, and so you're thinking that D is the one that will work. What are you putting in for N?
The number of sides.
Number of sides. So 360 divided by the number of sides is,
120.
okay, and that matches. And then 360 divided by 4, and that matches. And then 360 divided by 6, and that matches. Okay, did you try them all, or did you just kind of look at that one and think that was it?
I tried them all.
Okay. Before you really did?
Mhm.
Okay.
I had to.
Okay.
I'm not good at that kind of stuff.
Yeah, I mean, the only thing you could tell was that as the sides went up, what happened to the angles? They got lower. So you might think dividing, because the bigger the number you divide by, the smaller you get. So, okay, this is another pattern, but this is called a fractal.
Uh-oh.
Okay, do y'all know what a fractal is?
Isn't it like one of those
It's really neat the sun and it
It's
like
where the
repeats.
same thing
It
repeats
repeats.
in itself.
It repeats inside of itself. Kind of, yeah.
It's like a seminar on
You really?
Yeah, we had
Okay.
to like 2 years
Or
ago.
GT
I think.
or something?
Yeah,
Together
2 years ago.
Yeah.
Here's one fractal I've seen on a test before, besides this one, where they divided it into 9 blocks, and then they took another block and divided it into 9 blocks, and then they took the little block, divided it into 9 blocks, and they shaded the center of each one.
Will it ever get where you can't
Well,
divide?
physically it would get where you couldn't do it,
But like mathematically?
mathematically it would go on forever. Yeah.
It's sketchy.
Yeah.
You really think about it.
Yeah, it is pretty wild. Okay, so this one, what they've done is, so the student begins drawing a fractal by dividing each side of an equilateral triangle into 3 segments. Okay, so this is an equilateral triangle, and then they divided like this side into 3 equal segments here. Okay, and all the other sides. Okay, then the student replaces the middle segments with 2 equal segments to form the sides of the smaller equilateral triangle. So like they take this segment away and they put a triangle there. Okay, and then this is what you get. It looks like Chinese checkerboard.
Looks like a Jewish star.
A little bit, yeah, it does kind of. Okay, so how many sides does this triangle have to begin with?
3.
3. Now how many does this figure have? How many sides?
12.
12. Okay, each side of the triangle has 1, 2, 3, 4 sides now. And there are 3 of them, so 3 times 4 is 12. Okay. Right now, it says if you repeat the process on the 12 sides of the second figure, how many sides will the next figure have?
24.
Okay, you've got 12 sides, and what you're going to do is take one of these sides, like this one, divide it into 3 equal segments, and then draw the triangle. So now it has 1, 2, 3, 4 sides, doesn't it?
It's gonna have 36.
So all 12 sides now have 4 sides on them. So what are we multiplying by? 4. Be 48. Okay, so what about the next one? What would the next one be? You'd have 48 sides now.
192.
And right, each side would have 4 new sides. Be 192. Then you do 192 times 4 to get the next one. Okay,
768.
yeah. There is always a pattern.
3,072.
There you go.
12,200.
You just got to figure out what the pattern is to help you out. Or if you can't, fractals, they never go very far. You can always draw them. Okay. So you could draw all these and then you could count. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2 3, 4. Okay.
49,152. 96,608.
All right. He's got it.
Thanks, Matt.
Okay, if the perimeter of the equilateral triangle shown below is 37 centimeters. Now, what's perimeter?
The outside edge.
Okay, well, how do you find the perimeter?
Add them all.
Add all the sides. Okay, what's equilateral?
We're all the same.
We're all the same, so we have these 3 sides that are all the
Can
same,
we divide 37 by
and they
3?
add up to what?
12.3. Oh.
They add up to
37.
37, okay? So we can divide by 3, and we get, I shouldn't do that. 37 divided by 3 is 12.33.
Mm-hmm.
Okay, so each side is 12.33. Hey, Brian?
Oh,
Okay, and then it says to find the area. How do you find the area of a triangle? Okay. What's the base of this triangle?
12.3.
Okay, 12.33. What's the height of this triangle?
You gotta do Pythagorean theorem.
Right, we don't know it, do we?
You guys
Where is the height of this triangle?
from the base to the apex.
Good.
You gotta split the 12.3 in half. Right?
Okay, what's 12.3 in half? Split in half.
6.16.
And I think it rounds, is it 6.165? Yeah, so we'll do this with 6.17. So how would we find the height?
Pythagorean theorem.
And how would you do it?
You do 6.17 or 12.33 squared minus 6.17
Okay.
squared.
I'm going to do 6.17 squared plus b squared equals 12.33 squared, which is what you said too. Okay.
Got it.
All right. C is which part of the triangle is the C? Tell me.
The hypotenuse.
The hypotenuse, the longest side always. The other 2 sides are legs. So b squared equals 113.96, and then do the square root.
10.68.
Yep, 10.68.
So that's your height.
That is your height. Okay, so I'm going to plug it in here for my height. Still have the base at 12.33. Okay, so times 12.33 divided by 2. You get 65.8.
66.
Jay. You good.
Okay,
I did the special right triangle.
you did. You did. How?
Because when
'Cause
you
these are
split it with
60?
the height, that's 30, and then the one, it's already 60.
Right,
so then you
60.
split
So
it.
that one's 60, so this one's 30. Very good, very good. That works too. Okay, another scale factor problem. What does scale factor mean?
Dilation.
Multiply.
Getting bigger.
What you multiply
Or
by.
small.
Scale factor, if you think multiply every time you see scale factor, you'll get this right. Okay, this is easy to mess up. So this was not so bad, but when they give you the answer and they give you another answer flipped, then it's a little harder. Okay, this is triangle MNP. What's that little squiggly line mean?
Similar.
Similar. What does it mean if they're similar?
They're
Right.
proportional.
What's the same about them?
Same side, I mean, same shape.
Same shape,
shape,
same angles. Okay, what's different about them?
The lengths of the side.
Lengths of the sides. They're proportionally different. Okay. All right. What scale factor was used to transform MNP to RST? Okay. So what do you multiply the original triangle by to get the new triangle? So what do you multiply 7 by
You get
to get to?
2/7.
Okay. Does 1/3 work? You get 2.3. How about 7 times a half?
No, you get
3.5. And then 7 times 2/7.
Yes.
That one works. 7 times parentheses 2 divided by 7 is 2. Or you can tell that your 7's cancel, don't they? And you get 2. Notice it's not 7 halves. You gotta be careful about that. It's what you multiply the original triangle by to get the new one. Okay, last one. The figure shown below shows the positions of a surveying crew measuring the distance to a tree across the river. Okay. Which of the following best represents the measure of angle TAP? Where is angle TAP?
NLA.
Okay, it's the middle letter tells you the angle. So it's angle A right there. Okay, and it's from T to A to P. That helps to tell you exactly what the angle is. Okay, any ideas? It doesn't say
90
necessarily.
minus 32.
How do you know that this is 90?
Because those add up.
Right, because these add up to 90. That's the only way, not because it looks like the 90. Not because this is going north necessarily, but because these are parallel and these add up to 90. So what's 90 minus 32?
58.
Okay, if these had added up to 100, you would do 100 minus 32. All right? Okay. Any questions on any of those?